Go.
Hello everyone, we are Team 3 here today to talk about our story map, Sustainable Urban Planning in Miami. For our final project, we are aiming to map out the sustainability of potential new transportation line in the county of Miami-Dade. In the future, this map will include all major metropolitan areas in the USA. But for now, we have a prototype built for Miami-Dade in Florida. So first of all, we will introduce to our everyone. Myself, Ariful Islam. I did complete my graduation from Bowling State University, majoring geospatial science.
Hi, everyone. My name is Diego. I went to Florida State University, and I majored in geography, and I minored in international affairs.
And hello, everyone. My name is Jackson Davis, and I go to Cal Poly San Luis Obispo in California, and my major is geography with a concentration in data analytics.
All right, so why did we choose Miami? So I live in Miami, and I've noticed that like other car-oriented cities in America, there's insane urban sprawl combined with a lack of urban planning. To put this into perspective, Miami's built-up urban area has upwards of 6.5 million people, and there are only 2 rail lines with limited coverage and even lower ridership. Furthermore, Miami's very decentralized. And what I mean by that is that there's no large central business district. Instead, there's one somewhat large CBD in downtown Miami, but it's accompanied by a bunch of edge cities. And that makes commuter patterns go all over the place, and that causes chronic congestion throughout the county. Because of this glaring lack of urban planning, the county implemented the SmartPlan. So this plan seeks to expand public transit not only along the county's busiest corridors, but into places where there's a large transit-dependent population. However, we want to make our own edits because we believe the SmartPlan is not nearly as extensive as it could be. And today we will show you our own spin on how Miami should really expand its public transportation system. First of all, we want to compare Miami to other cities. And when you do that, you notice that cities of the same size have a much more extensive public transportation system, with the Bay Area being an example. And it's not only restricted to the US, you have cities across the world that also have a much better public transportation system. Berlin, for instance, mind you, was divided, just over a few decades ago. And look at the public transportation system it has now compared to Miami's. You also have Singapore, another city around the 5-6 million mark, and look at the public transit system it has as well. And then finally, we're going to zero in on Madrid, which is another mid-sized city with excellent public transportation.
And so in order to start this project, we needed to get our data from somewhere. And a lot of the data that we did get was from the Miami-Dade County Open Data Hub. So they already had existing data. Down here is a map of their smart plan that they had proposed. And so you can see that it does cover a large area, but we thought that this smart plan was not as serving as it could have been to the public, and that there definitely could be more lines and stations that better serve the city and county of Miami.
The thesis of our project is we aim to create a story map for Greater Miami that highlights how sustainable urban planning through the creation and implementation of non-vehicle infrastructure will better serve the people and environment of the area.
So we determined that we would focus on expanding non-vehicle infrastructure and find the best areas to expand the non-vehicle infrastructure of the county. We mostly focused not only on extending metro rail lines, but also adding new parks and bike lanes, particularly within the areas surrounding the proposed metro stations. So down below here is a simplified process of our steps that we use to complete the project. So first we had to gather data, then we had to find a formula to determine the carbon emission reduction. And so below here, this is our formula that we used. To find the CO2 emissions per corridor, we got the median traffic per year per each section of the transit plan that we covered, each corridor, and then multiplied it by 4.6, which is the average metric tons per vehicle, according to the Department of Transportation in the US. And then we multiplied that emissions per corridor by 0.9. And 0.9 indicates a 10% traffic reduction according to the SMART plan and all the research that they did, that a 10% traffic reduction would be implemented if that SMART plan and those transportation lines were made. And so that would give us the CO2 emissions per corridor after the SMART plan. And then after this, we digitize new non-vehicle infrastructure based on population density and also to destination areas. And then we calculated the numbers based on our formula above for all new vehicle infrastructure or all new non-vehicle infrastructure corridors. And then we performed a suitability analysis for new potential green space, created 3D scenes to visualize the areas connected, and made cartographic decisions and edits to finalize maps, CO2 emission data, and the corridors.
In order to achieve goals and complete our project, we had to consolidate and visualize our data by utilizing various ESRI products and tools. The resource we used include but not limited to, for example, ArcGIS Pro. We use suitability model in that, which is used to identify the best location to site things or green areas or to preserve for this specific study area. We use offset tools builder for starting a line that creates a gap at a specific radial distance from the first point location, and we click in the map and first vertex that in the polyline features. Also used ArcGIS Online, ArcGIS R1, and also Living Atlas for 2022 population density of SG. So what we get from that key map for reference of our tutor project, based on the population density, we decided to expand our plan for urban sustainable for map out the sustainability of potential new transportation lines in the county of Miami-Dade. Also used story maps for presenting our projects, and the intended user for our project range from urban planners to the general public, as the smart plan serve as a tool to raise awareness on options for sustainable transportation in the metropolitan area.
All right, so in order to visualize what we're really up to in terms of expanding public transit, I want to show you guys a back of these images, right? So here you have the existing public transit in Miami, which is not extensive in any way, shape, or form. Then you have the smart plan, which is somewhat extensive. And then here you have our proposal, which you're extending to adjacent county, and you're bringing this segment down 27th Ave, which isn't seen on the smart plan, for instance. So I'm going to explain each and every corridor now. You can just scroll down real quick. Beautiful. All right, so this is our first line. This is a heavy rail line, commuter rail, in fact, to Fort Lauderdale, which is the county seat of the second most populous county in the state. And not only do you have Fort Lauderdale up there, you have another big airport there. You have the Port Everglades, which is the second largest cruise ship port in the world. And on top of that, you'll see a reduction from 48,000 vehicles a day to 38,000 vehicles a day after the smart plan is implemented. And then in terms of CO2, you'll see a reduction from 195,000 tons to 158,000 tons after the smart plan. All right, so let's move on to the east-west corridor. Here you're connecting Miami's western suburbs to the city, and it stops in the airport as well. So here you'll see a reduction from 179,000 vehicles to 161,000 vehicles a day. And CO2 emissions will be reduced from 823,000 tons to 668,000 tons a year. So let's shift to the Green Line extension. So initially the Green Line finished at Palmetto Station, which is part of the existing Metro Rail. So we want to extend it to Miami Lakes, which is an underserved suburb. And if that were to happen, you'll see traffic reduction going from 73,000 vehicles to 66,000 vehicles, and CO2 reductions going from 339,000 tons to 274,000 tons a year. And then the North Corridor actually connects Hard Rock Stadium, and there you have you had the Formula One there a few months ago. The Dolphins play there, Miami Hurricanes play there, so it's a pretty big destination. So you want to connect that to the city. And if that were to happen, you'll see a reduction from 37,000 vehicles to 33,000 vehicles a day, and CO2 emissions will be reduced from 173,000 tons a year to 140,000 tons a year. Yep. So now let's shift from heavy rail to a metro mover, and that is a people mover. So it's definitely much smaller scale. You have a higher frequency of stations, and this is more feasible to implement in the inner city of Miami. So that's what we're going to do here. So let's start off with Wynwood and the Health District. So this segment is going to connect Wynwood, which is a huge tourist area in Miami, and the Health District, which is the second largest health district in the country after Houston's. And if this were to happen, not only you're connecting destinations, but you are also reducing vehicles a day from 16,000 to 14,400, and CO2 emissions from 76,000 to 59,000 tons a year. So let's shift over to Flagler Street, which is one of the main streets in town, also has a lot of traffic going on there. And if this were to be implemented, you're seeing a reduction of 30,000 vehicles to 27,000 vehicles a day along this segment of road. And CO2 emissions will reduce from 138,000 tons to 111,000 tons a year. Another segment that's pretty important is Gaiocho to Coconut Grove. Gaiocho's where Little Havana is. That's another big tourist zone, so why not connect that to the city? So if this were to happen, you have a reduction of 35,000 vehicles to 31,000 vehicles a day, and emissions will be reduced from 161,000 to 131,000 tons. And Coral Way, the brown segment right on the bottom, you will see a reduction from 26,000 vehicles to 23,000 vehicles a day, and a reduction of 109,000 tons to 98,000 tons a day. And Coral Gables is another pretty big central business district per se in Miami. I'd say it's the second largest after downtown, so that's a really important destination you want to connect job-wise. All right, so I'd say this is the most important part of our extensions of the Metro Mover, especially it's more tourist oriented. So we're adding 3 stops at the Port of Miami, which is the largest cruise ship port in the world. And you're throwing in the Metro Mover into South Beach, which is arguably Miami's biggest tourist hotspot. So if this were to happen, once again, you're not only connecting destinations, but you're being nice to the environment. So you'll see a reduction of about 4,000 vehicles a day, and a reduction from 185,000 tons to 167,000 tons of CO2 a year. All right, so for our final extensions, we are going to shift a bit north to one of the more denser parts of town. This is all in Miami Beach, so you have a bunch of high rises along the coast, a bunch of people living there, so we decided to extend it. Why not? So here you'll see a reduction from 63,750 vehicles a day to 57,375 vehicles in the mid-beach, North Beach segment, which is a light green down here. And CO2 emissions will be reduced from 293,000 tons to 237,000 tons. And you move up north to Sunny Isles, which has a bunch of high rises as well. You'll see a reduction of around 4,000 vehicles a day, and CO2 emissions will be reduced from 176,000 to 159,000 tons a year. So here we have like a more simple map. Here we're just highlighting the full extent of our potential transit corridors once they actually come into fruition. And if they were to come into fruition, the numbers are crazy. So you'll see a reduction of 44,850 cars each and every day. And you'll see a reduction of around 617 tons of CO2 a year, which is huge.
Yeah, and so we have here the areas connected by our plan in 3D below, and then also a map of our suitability analysis that we use for the parks. So the suitability analysis takes land use and population density, and the land use most suitable for green space was determined and in the most populous areas, and that's what these parks are. And then here we have images of the different destinations. So here's the Miami Health District, which is the second largest concentration of hospitals and medical facilities in the country after the Texas Medical Center. And so connecting this destination could be important for a lot of people and lots of jobs here. So there's different stations. These little pins are the stations. Building new stations is very important. Connecting them through these green bike lanes here, connecting potential new green space. This is determined through the suitability analysis as potential green space using like parking lots or other areas that might not be as needed if more public transport is implemented. And then here is those bike lanes again and a greater view of the whole area. And then downtown Miami, which is South Florida's like principal central business district, the largest probably in Florida. So lots of jobs here, lots of high rises, very important to connect this to lots of different areas of town. So there's lots of bike lanes that were digitized here, added more new potential green space in the downtown area that could serve for tourists and serve to better the environment. Here's the Flagler Street extension, just showing stations going out into densely populated areas. then more potential green space and more stations just along the river here. Then down here is Miami Beach, which is the world famous like tourist hotspot, probably one of the most famous tourist hotspots in Miami. So here you can see that connecting bike lanes and connecting it with the stations to the ports, it would be very important. Also connecting the densely populated beach areas of the north and to the rest of Miami is very important as well. So here's some more stations along, see these high rises here in the north that could potentially connect these densely populated areas to the rest of Miami. Then here's Miami Lakes, which is a suburb. Connecting suburbs is very important. Having this one station here potentially could bring more high rises, more buildings, and densely populated areas, which could also reduce emissions, more green spaces again, and just more bike lanes to revitalize this suburb a little bit.
So for completing this project, we have some challenges and setbacks. For figuring out the formula to use the calculate emission is the most challenging one. Also consolidating the lines into one loop, issues with merging and issues with uploading to online, fixing a lot of errors unknown to us. So what will be the next step for our project? There are other elements we were considering featuring of the story map, particularly the economics version of our smart plan. In other words, we wanted to consider the cost of this plan as well as the revenue this change to the transit system would generate. So because a substantial amount of city's GDP is lost to traffic delays, so it would have been interesting to see highlight how much money Miami would save would the reduce traffic and commute the times. So here is our final thought and remarks that we learned from doing this project. Our proposed metro rail lines would bring down emission by a significant amount by reducing car traffic, making transit-oriented development in geographically constrained cities with lots of urban sprawl like Miami can encourage less single-family home zoning, and this will also help to reduce emission and make the city more sustainable. This new infrastructure would decrease the commute time by rail or car for all citizens. Also, this infrastructure could potentially revitalize suburban neighborhoods to become more workable or less car. Also, we learn how to utilize suitably modular, for example, to define the problem, identify and define the criteria, transform value, common scale, and analyze the result. Also, we learn how to extract building heights to create from a 3D scene from the ground elevation along with the outline of each building footprint and subtract it from the building elevation. Also, we learn how to use ArcGIS Urban, which is like a solution-based application that's GIS technology to urban planning to streamline plan creation, analyze the impact plans, and visualize the current plans. So those are the resources and the works that we use for preparing our project. Thank you so much for attending our presentation. We hope you enjoy our story map. Let us know if you have any question.